Okay, everyone. Good morning. Hopefully, you guys can hear me, and I hope you guys are staying safe and doing as well as you can. So I think we've got most of the class in, but a few more late additions. And so let's see. I got an email from one of the students. I don't know if he or she is logged in yet, but there's some problems opening the documents from the Blackboard page. And have you guys had any issues opening the documents from the Blackboard page, like the Word files, the Excel files, the PDF files?
No.
No. Okay. Well, so I think I've had this issue from a few students in the past when I switched to WebEx. I don't think it has anything to do with WebEx, but I think sometimes if you're trying to access the documents from your smartphone or a tablet, it might not have the Word, might not have Office installed or Word or Excel or the PDF reader, etc. And so I think if you do it on a computer or a laptop, there shouldn't be any issues. But if there are, I need to make sure you guys can get the documents. So is the person that emailed me like 10 minutes ago here for they have the issues? All right. Well, I'll bring this topic up again later, but I want to make sure that you guys have access to all the files. And so if it's a phone thing, a Blackboard thing, a computer thing, I can make sure you have the documents. So if it's just that one person, I will email you the documents personally. But if it's a bigger issue, then I will see what I can do to address it. But it really hasn't been. I haven't had this issue much in the past, but if you guys have any problems opening the documents on Blackboard, please let me know. Okay, so let's first see if everybody is having any issues turning in the homework. Okay, so it looks like most of you have figured out what to do to turn in your homework. Just you go to the appropriate thread and you post a new thread and you attach your document, whatever format it's in. And so there's a few more students that have to do that. You have it's due today, so you have until I guess midnight tonight. I didn't really specify a time. So if you're one of those, it looks like 3 students who hasn't turned in homework 1, 2, or 3, make sure you do that by tonight. And if you have any issues with that, please let me know. All right. So everybody, any issues turning in the homework or any problems with the homework from the first week?
Nope. No.
Okay. Great. So let's see. All right. Let's go back to the syllabus. Okay. And so just to clarify, so like last time we decided we're going to do on our meeting days, we'll do our full meeting from 8:30 a.m. to 1 o'clock, and there'll be a little 30-minute break in between. I think last time it was from 10:30 to 11, right in the middle. And so you guys, I think everybody figured out that you got the new meeting information and the ones I set up before. Just disregard those, and there's only one meeting. And it looks like everybody's figured out where to go for that. So it looks like we are good on the WebEx information. All right, so last time we covered chapters 1 and 2, and you guys have done the homework for those, and also chapter 3. If you missed any of that, everything is on the YouTube channel where I posted my stuff for this 525. Okay, so you can always watch that again, including today. We're recording this as well. All right. So what we're gonna do today is we have a couple chapters to do. Chapters 4 and 5, and then we didn't get to the elasticity homework last time. So I think we'll do that first. And so let's go to this. Let's go back to the chapter 3 material. Okay. So here's the chapter 3 stuff on Blackboard. All right. We did the homework, or the primary homework for chapter 3. You guys have already done that, most of you. And so the elasticity homework is just it's kind of the same analysis, but you can do more questions and you can actually use some data. And so here, we're going to do some analysis in Excel, Microsoft Excel. And so if you have any problems accessing Excel, I know that some students are, well, all students are taking the class remotely, but you're in various locations. And so if there's any issues having Excel, then let me know because I can help you with that. All right. So down here where it says elasticity homework, let's just open that up now. So this is what it'll be due in 2 weeks, along with some other things. But I pushed this back to 2 weeks from now. Okay. So if you did the homework from chapter 3, this is the questions you answer here are going to be similar to that. The only difference is you have to do the analysis in Excel. So you have to estimate the log linear equation and then identify the elasticity. All right, so let's go through the question, or maybe the first one. Okay, so I gave you guys some data sets, which I'll show you, and they came along with the textbook resources. And so you're going to use some of these data sets to go into Excel and estimate the equation. So last time we specified that to get the elasticity that we want to look at, you got to put the data into log linear form, natural log form. Now some of the data sets already have it in that form, and some you have to do it, but it's pretty simple to transform it. So the first question 12, you're going to estimate this log linear equation. You're going to have data on natural log of quantity, and you're going to see how that is affected by the natural log of price and the natural log of income. Okay, and I'll show you how to do that in Excel, and then so LNQ is the natural log of quantity, LNP is the natural log of price, and LNI is the natural log of income. Okay, so the questions again are similar to what you did in the chapter 3 homework. The only difference is you have to do the analysis first. So part A is going to be include a screen cap of your regression results that you're going to get from Excel. So before you do any of the questions, for any of these questions, you have to know how to do it in Excel. So let me show you where the first one is. All right, so to do part A for each of these questions, you have to go to the appropriate data set, which is posted on Blackboard. Okay, so right here, you should see under the chapter 3 Blackboard material that I have a little section for data for elasticity homework, which goes along with each question. So the first one we're looking at now is question 12. So open up the Q12 file. Okay, so here you see that there's a bunch of observations for the natural log of quantity and price and income. So you're trying to see, you're trying to estimate the elasticities like we did last time and see how responsive quantity or demand is to price and also income. So down this column, you have each about 50 observations where you have the natural log of quantity and then the associated natural log of price and natural log of income at that observation. So what you want to do is use Excel's data analysis tools to run a simple regression, and then once you get the coefficients, you can just talk about those elasticities like we did last time. So just to kind of summarize, last time the homework, okay, so here's your homework chapter 3 that we kind of did together in class during the first meeting. So you did the same kind of thing, and remember this is what you looked at. There's this big screen cap or printout of the summary output. I'm going to show you how to get that output in Excel. So once you get this, once you do the analysis in Excel, you should see something just like this, and then you can answer the questions just like you did from last time. Okay, so the goal, in addition to answering the questions, is to get this output that you can talk about. Okay, so we're going to basically start from scratch and use the data to get this summary output. Okay, so here we are back to the data for question 12. All right, so first thing is if you're using, so you don't have to do this right now, but you have to do it at some point. And so again, if there's any issues having access to Excel, then let me know so I can figure something out for you. I'll make sure that you have some access to Excel and can get to do the data analysis. So as you're doing it in Excel, what you want to do is make sure you have the data analysis feature. And I showed you guys how to check or load the add-in last time. And so let me show you again because all right, so if you're using Excel and you click on the data tab, if you have the option available, you should see the data analysis up here like I have it. And often you have to specify the add-in, which I'll show you how to do. So if you don't see data analysis in your Excel, you probably still have it, and this is how you access it. Alright, so in Windows, it's a little bit different in a Mac version, but I can show you that too, or talk you through it. But you want to get to your add-in. So in Windows, click on the File tab. Okay, then go down to Options. Alright, and then in this box, you should see the add-ins option. Click on that. And then down here where it says Manage the add-ins, click on the Go button. Okay, and this is the box you're trying to get to with the add-ins options. Alright, so if you see the Analysis Tool Pack and it's not checked, it should be the first one alphabetical-wise, and so that's the one you want. If you see it there, check it. Alright, mine's already checked, but if yours isn't checked, then check that box and hit OK. All right, and then when you click on the data tab in your Excel file, you should see that you have, if you were able to do it successfully, you have the data analysis option. Okay, so again, you don't have to do this right this second. You can just watch me do it, but just any issues getting the data analysis? So were you guys able to access data analysis?
Can you show us with the Mac, please?
Yeah. Yeah, so, well, I can't show you with a Mac, but I can talk you through it because I don't have a Mac, but, so,
Okay.
yeah, so let me, okay, you need to go to, like, let me, okay, here, so try this. I've helped my students in class, so I could show you, but I can't remember, like, but I know it works. So if you go click on the Tools menu, which is like at the top of your Mac, and then you should see Excel add-ins. So that's the first step. You see that?
Yes, I do.
Yeah. So at the top, like from one of the drop downs, just click on Tools, and then click on Add-ins, and then does it take you right to that box that looks like with the features you can check?
Yes, it says Analysis Toolpack and Solver Add-ins.
Oh yeah. So click on the Analysis Toolpack. Once you get to that, yeah. So actually, it's easier on a Mac if you have the feature. And so yeah. So what you want to do is click on Tools, then get to Add-ins, and then when you get to this, let me show you what I think it looks like this.
Oh, it's different answer.
Yeah.
Yeah, my the Microsoft version is the Chinese version, so I didn't find the option that we need to add in. So can you wait about 2 or 3 minutes? I will check
Okay.
what's the option that I need to add. Okay.
Okay.
All right. Thank you so much. Yeah. Just 1 second.
Okay. So I think when you're trying to do it with Mac, with the Mac version, that when you click on Options and then the add-ins, it takes you to this box, hopefully. And then the one you want to check is this first one, Analysis Toolpack.
Okay.
Okay. And then once you check that and hit OK, it should appear under your Data tab when you go back to the Excel file.
Oh, yes, data analysis. Okay.
Yeah.
Thank you.
Okay. Does that work?
Yes.
All right. And so I'm waiting a few minutes for some people to access theirs. So while we're waiting a few minutes, anybody else need help getting the data analysis? So you'll know that you have it when you're here. So when you're on the data tab at the Excel file, you should see it appear right here. So that's when you know you have it. Okay, and I'm not sure that if you're using the online only version, I don't know that it's available. It might be, it might not be, but if you're using the online version only, let me know if you can't access it.
I think I have already added the ins, but I'm not sure. So we can go ahead right now. Yeah.
Okay, so do you see it here, or in whatever version does it say data or something like data analysis?
When I try to add ins
Yeah.
and open the analysis the pack, the pack is not open. Yeah, it's got nothing.
Okay, well, if you see it, you just have to select it. So if you see it, that's good. So if you see the option, just click on the box and hit OK, and then it should come up.
Yeah, it should be work. Yeah.
Okay, so it works?
Yeah, it should be work. Yeah.
Okay.
Okay, thank you.
Okay, you're welcome. All right, so let's, if there's any more issues, just go ahead and, tell me your issue or post it to the chat. But, let's at least, try to use the data analysis to do this, analysis. Okay, so, we're at this Q12 file with the data. Alright, so click on, and then the good news is that every time, if you check the add-in, as long as you're using the same computer, that every time you open Excel now, it should be there. Okay, and so data, and then click on data analysis right here. Okay, so it's an alphabetical order, so scroll down and click on regression right there, and then hit the OK button. Okay, so you should be at this regression parameters box, hopefully, when you choose the regression and hit OK. And so for here, you have to specify a few things, and let's start by choosing the Y range, which is the dependent variable, which is always going to be, in our case, the Q variable, or the LNQ, because we're always trying to see what affects demand. So to choose the Y range, you can click on this button. Alright, so once you choose that button, you want to choose the whole, the whole A column, because that's the LNQ. So you can just go over here. Okay, and so with the mouse or the keyboard, you can select the whole range, which looks like A1 to A50.
And we're including LNQ in it too? Like not just
So yeah, include the title, yeah.
okay.
Alright, so A1 to A50, yes, and then hit the button again. Alright, and the X range is going to be all the other data together in a group, because you're putting the X data as one range. So for the X range, click on this button and choose all of the B and C column, which is going to be B1 to C50. And then hit that button, and so always make sure that the ranges are the same length, like it's going 1 to 50, so it's got to be the same number of observations. Okay, and so since I told you to choose the title as well, the A1 and B1 and C1, make sure you choose that labels box right there, so click on this box. Alright, so make sure that's checked, and that way it will, when you do the summary output, it'll show you the name of the variable, which is very helpful. Okay, so that's all you have to do this, and so specify the X range, or specify the Y range, specify the X range, and then choose this box that says label. So it should look like this. Were you guys, so before we hit OK, is this working?
Yes.
Alright, so if you got that specified, hit the OK button. Alright, and you should get depending on your options, usually it just puts it into another tab like this, and you get the summary output. And this is similar to what we looked at last time when we did homework 3. Okay, so did everyone get something like this?
Yes.
Alright, so again, if you have any issues or miss any steps, let me know. We have 2 weeks to do this, but so you don't have to keep up 100% right now. But if you are doing that and something happens, let me know. But this is what we want. So I'm gonna here's what we're looking for. So here's okay. So you want to when you're doing your homework, you want to include a screen cap of the summary output, which is this. So I'm gonna make it so there's not so many decimals, and so that way it's a little bit easier to read. So if you want to do this, you can. If not, it's just a preference. So if you click on that triangle up there, which just selects everything, I'm just going to format it to show only 2 decimals, and that way it's a lot easier for me to talk about it or translate it. Alright, so if you go to Home tab and then the Format menu, and then right here where it says Format Cells, you've probably done this before, but just click on that. Alright, and I usually like to have the number option with the commas, and then 2 decimals. Alright, so if you want to keep it at 2 decimals, it's probably easier to write and talk about. Alright, so there you go. So everything is 2 decimals now, which makes it a lot easier to translate. You don't have to worry about 6 decimals or whatever it was before. And then you can see that some of so you can go through and widen the columns, or if you want to just do it in one step, you can also do this. And under the Home tab where it says Format, if you choose Format and then Auto-Fit Column Width, then you can see everything a lot nicer. Yeah, there we go. So that looks a lot nicer to see. Okay, so let's see what we need. So first you want to do when you're doing the homework is this is the summary output. So part A. Okay, so part A was just include a screen cap of the summary statistics or the regression results. And so that's what you have here. And so all you have to do for this part is take a screen cap, or you can copy and paste, but you want this to go into part A. Okay, so you can take a screen cap, or you can use the snipping tool. So you can use this on Windows. I know that there's a keyboard shortcut, but I can't remember what it is. And so whatever you did to take a screen cap of an area on your computer, you can do that. So if I use this, the stepping tool, alright, so I took a screen cap of it, and I'm just going to put it here. I saved it as a picture file, a JPEG or a PNG, whatever it is. Alright, so basically you want to get this set, alright? So just take a picture of the summary output from the Excel file and put it into your homework solutions, whether you're using Word or whatever, or you can make it a PDF, but this is the thing you want for part A. So the summary output or the regression results is just this. Okay, so were you guys able to do, or at least know what to do for this?
Yes.
Okay, so part A is just once you get the analysis, just put a picture of it right here so you can talk about it. Alright, so you basically did what I did in chapter 3 homework, this. Yeah, so that's exactly where that came from. I did this in Excel, I took a picture and I put it there. Alright, so you've already seen this, and now you know how to get it. Okay, so let's see. So for all these questions, this is what you're going to do, and I'll do one as a full example, but it's going to be number. It's going to be number 19 because there's multiple states, and so I picked one as an example. But let me just, for all these, there's 4 of them. All right, so you can open up the Excel file, and so there's um, all right, so there's question 12, there's question 18, there's question 19, and there's question 20. Now there's one separate Excel file that I posted right here. So there's, you see one for each of those questions. So whichever question you're doing, just open up the Excel file and do the data analysis. You don't, when you turn in your homework here, oh, it looks like someone, oh no. All right, so when you turn in your homework here, which I was doing 2 weeks, along with some other things, but for this, you just need to turn in, when you go here, just create a thread like you did before and attach your Word document or PDF, or you don't need to include your Excel file. So you don't need to add your Excel files or data, just the final document with the screen caps. Okay? So, Alright, so you don't need to submit Excel files with your homework. I mean, if you forget and attach it, that's fine. I'm just going to look at the Word document or the PDF for the final version. Alright, so for each of these, it's the same process. So part A is you're going to do the data analysis in Excel, open up the data file, and do the regression like we just did, then include the screen cap. And then part B is going to be write out the equation using the coefficients. Part C is going to be interpret the adjusted R squared. Part D is going to be are the coefficients for your explanatory variables, which are the x variables, are those statistically significant? And then part E, is interpret the coefficients for your explanatory variables, but you need to do just the significant variables only. Okay, so we did basically parts B through C for homework 3. But I'll do one more example so you guys can do this. But so one of them, alright, so question 19, there's a bunch of different states, and so I assigned you guys, I'll show you, but I assigned you guys one state to do, and then I'll do one state as an example, and then you can kind of use this example to do the rest of the homework. Alright, so for question 19, you're going to estimate this equation where you got the natural log of quantity is a function of the natural log of price and the natural log of income. Okay, and you have data that I'll show you. This KBC Brewing Company sells microbrews in a 7-state area, which is Illinois, Indiana, Michigan, Minnesota, Mississippi, Ohio, Wisconsin, and then each student's going to be assigned one state. I made a spreadsheet to show you which one you're assigned to. Okay, and so I'll show you guys what state you should do. I'll do the other state, which is in Illinois, I think. One of them I chose as an example. So I'll do that one as an example, and then you guys should be okay for the rest of the homework. Okay, so for this one, number 19. Okay, so open up this one, data for elasticity homework, question 19 states. Alright, so here is the tab for each state. Alright, and so you're only going to do one of these. And then if you want to see which one you're doing, alright, so sorry, we got a lot of Excel files, but right here where it says elasticity homework, this 219 state list, you can open that up. Alright, and so this should be updated to include all students. We have 29 students now, and so basically, which one did let me see, was in Illinois? Yeah, so I did Illinois as an example, which we'll go through. Then the other 6 states, I divide you guys into groups of 5 or 4, just based on the alphabetical order. Alright, so look for your name. So if you're in the first group, you're doing Indiana. If you're in the second group, you do Michigan and so on. So you're just do one state based on your alphabetical, assignment. So just look for your state.
Professor, it doesn't mean that you're working in a group though, right?
No, you're doing it individually, but I just didn't want to have.
Okay.
I only want you to do one state, and I figured if we have multiple states, you guys might as well just do them all. So yeah, just if you're not working in a group, that's the state you have to do.
Okay, thank you.
Okay, so that's the state you have to do, and the corresponding states or go to this Excel file again. Okay, so if I find you Indiana, this is the only one you have to do. The rest of the data you can ignore. Okay, the 5 of you that do Michigan, go here. And you got Minnesota, Mississippi, Ohio, and is that Mississippi? Yeah, Mississippi. Okay, and then I will do, or I've done, the Illinois one as an example. Okay, so I'll do this one for you guys to see how to do it, and then you guys should be okay, I think, on the rest of the homework. Everybody good so far?
Yes.
Okay, so again, just do your one state that you're assigned. You don't have to worry about the other ones. So the only thing you have to do differently in this one is you have to convert your quantity, price, and income into a natural log version so you can get the elasticity. All right, and so it's pretty simple, but just all right. Let's just make. This is my example for Illinois. So just do this for your state. All right. So let's make a new couple variables in columns D, E, and F. Okay, so this is going to be the natural log of quantity. This column will be the natural log of price, and the last one will be the natural log of income. So all you have to do is just use a simple formula to take the natural log of each of the raw variables. So starting here in D2, let's just type in equals. The LM function is the natural log, and then you can just choose the first one, which is A2. Okay, so there it is. That's the natural log of 575, and then you can just use the same formula to apply it to the rest of the range like this. If you drag it over, this should be the natural log for B2. Okay, and this should be the natural log for C2, alright? And then Excel knows what you're trying to do, so if you select these three together, and all you have to do is double click the bottom right corner like this. Okay, and that should apply the natural log to all of the appropriate variables, alright? So just doing that, it gave you the natural log of all the other quantities, prices, income in the appropriate column.
Can you do that one more time, please, when you click all three together?
Yeah, sure.
You get all of them?
Yeah. Okay, let me, okay. So, we're to this part?
Yes.
Okay, so once you get these three, you can tell Excel to apply the same formula down the whole range. So just together you can select, what is this, D2 to F2, like that. All right, and then when you have them all selected, if you take the mouse right here, or if you're using a mouse, there should be a little box at the bottom right corner. See that?
Mm-hmm.
And just double click.
Oh, okay. Thank you.
It's just a shortcut. I mean, the other way to do it is like this. You can otherwise drag it down just like this. But if you had a much larger column, it's a much quicker shortcut. So yeah, it's just a shortcut for dragging down the formula. Okay, so did that work?
Yes, thank you.
Oh, you're welcome. Okay, so I think this is the only data set you have to convert to natural log, but you can see it's pretty easy. So everyone sees how to convert to natural log. Just take the formula and apply it to the appropriate calculation. Okay, so once you get your data in natural log form, then you can run so this is all for question 19. All right, so you're trying to estimate this equation, which you had to do the transformation first. Okay, so once you do this for your state, just go back to the file. Okay, and then back to data analysis. All right, so just go to data, then data analysis again. And the same thing, choose the regression option, just like last time. Okay, so the Y range is the natural log option. So the Y range, click on this. It is the whole D column, so D1 to D51. And the X range is the E and the F column. So that's E1 to F51. And then again, make sure that labels box is checked. So once you convert it to natural log, like we did, the column A, B, and C, you don't need that for your data analysis. So that was just the actual data, but once you get into natural log, that's the data you want for your regression. Okay, so then you can hit OK again. Okay, and you should get another summary output tab for your whatever state you're doing. All right, so this one again is for Illinois, but only do the analysis for your state that you were assigned to based on that spreadsheet. Okay, and then again, you could format the decimals and make it a little more viewable for when you cut and paste to the screen cap. All right, so I can do that again. Okay, and you can also auto fit the width of the columns to make it so you can see all the titles. Okay, so you should get something similar. The only difference with this one is you had to transform the data into natural logs first. Okay, so was everybody able to get this far if you're doing it? Any questions on this part of the question? Which one is this? The 19, question 19?
Nope. Okay.
Alright, and then again, this is the only one, so depending on your, depending on your assigned state, your answers are going to be different, except for the people in your group. So all the other ones, you're going to have this, you should have the same, screen cap or summary output, but this one, it should only be similar to the other students that are doing your state. Alright, so nobody should have anything that looks like this because, I'm the only one that did Indiana. Okay, and so then you've got this far, so you want to take a screen cap of this. Put it right there for part A, and then answer the question. So for all of these, there's 4 of them. The first step is to go open up the Excel file and do any transformations if necessary, and then run the data analysis, and then take a screen cap of the results. Okay, and so your answers should be similar to what we did in the chapter 3 homework, but I posted, let me see what I posted. Okay, here's my example for Illinois, which I think we just did, but yeah, so I've already posted the Excel file for the Illinois example, so if you need to look at that, you can look at my formulas, and it should look something like this. Let me run through the rest of the questions for this one, just so you guys are good on answering the questions. Okay, so for question number 19, my example was for Illinois. So let me get the screen cap in there, then we'll answer the rest of the questions. And then I think you guys have enough to do the homework. Alright, so I took a screen cap. Let me just paste it in here. Okay, here we go. So here's part A, question 19, and let's answer the rest of the questions as an example. Okay, so first part for all these questions is part B, which is to write out the equation using the estimated coefficients. Alright, so you start with this equation. Okay, and then put in the parameters that you get from your regression. They're going to be different from mine for this one because I have a different state. Alright, so let me just, this is for Indiana. Alright, sorry, this is for Illinois. Okay, so the natural log of quantity is a function of the intercept, which is right here. When you screen cap, it's, for me, it's 0.99. Alright, the coefficient for L and P is right here, 0.35, and the other one is 0.14 from this column here. Alright, so there you go. This one's similar to the last homework we did, just plug in the coefficients that you get. Alright, part C, interpret the adjusted R squared. So the adjusted R squared, just write it down, and then talk about what percent is explained. So mine is 0.05, which is really low. Okay, and remember that the adjusted R square is a percent of explained variation in the dependent variable, which in this case is always going to be LNQ. So I explain only about 5%. Okay, part B is going to be to determine if one or more so if you have one variable, it's only one. If you have two, it's two. But so for question 12, you have ln P and ln I. Question 18, you only have ln P. Question 19, you have ln P and ln I. And then question 20, you have ln P and ln A, which is the advertising one. Okay, so for this one, you need to check for ln P and ln I, if they're significant or not, by doing what we did last time, which is look at the T statistics. Okay, so here's the T-stats for ln P and ln I, respectively 0.38 and 2.17. Okay, and remember that the rule of thumb is if this number is bigger than 2 in absolute value, then it's significant. If it's less than 2 in absolute value, then it's not significant. So we have one that is and one that isn't, but make sure you do the check for yours. So this one, definitely less than 2. But for LNI, it's big enough that we can talk about it. So this one's bigger than 2. So this one would be significant. All right, and then the last part is part E, where you can interpret the coefficients like we did last time for the ones you get after doing the data analysis. Okay, in part E, it's always going to say interpret the coefficients for your explanatory variables and the significant ones only. So for this one, I'm only going to interpret ln I because ln P didn't prove to be significant, which means that there really isn't a relationship confirmed in the data. And so the interpretation doesn't really matter because the correlation wasn't strong enough. Okay, so only do the ones that are significant, and for this one, I'm only doing ln I. Okay, so the coefficient for the natural log of income, which would be the same thing as you had in your equation, is 1.14. Okay, and you need to interpret that. There's usually 3 items you can say about it. So the first thing is, what type of elasticity is it? Okay, so it's the income elasticity. It's the income elasticity because you're looking at how demand responds to income changes. And the second thing is it inelastic or elastic? Okay, so 1.14, if we took the absolute value of that, the coefficient is bigger than 1, which means that the demand is more responsive than income percent-wise, so this would be elastic. All right, and the third thing, just interpret the percent-wise what that coefficient means. So this is the responsiveness of demand to changes in income in percent-wise. So we would say that when income changes by 1%, what happens to demand? Okay, so when the income changes by one unit, which is 1%, when income increases by 1%, quantity demanded increases over this data set by 1.14%. Okay, and then just remember that if your coefficient is positive, it's a demand response with increasing. If it's a negative, like it often is with price, then demand decreases. So make sure you pay attention to the coefficient or the sign of the coefficient. Okay, so this is how you need to interpret all the 4 questions for the elasticity homework after you get the printout. So questions on this? Okay, everybody's good. All right. Well, if you do have questions, you have 2 weeks to do it. But if you have questions, you can send me an email, or hopefully not the last minute. But if you do, okay. So I think you guys are good to go for the elasticity homework. That is due next week, our next meeting date, which is next month, July 11th. All right. So again, once you're done with this one, that goes right there, and that's your elasticity homework. So you just need to turn in the one document where you answer all 4 questions with the screenshot and do the analysis like I just did. All right. So everybody's good on this? How to do this assignment for next time?
Yeah.
Okay, so great. And if there are any issues, especially with Excel, with data analysis or whatever, then please let me know. But I think most of you are able to do it without any issues, but I don't know. Alright, so we're going to start chapter 4, and we'll take our break at 10:30 again. So I think what time is it? About 9:45. So I'll try to stop at 10:30, but make sure that if I'm going over, that you let me know so we get our break at the appropriate time. But let's start with chapter 4, and yeah. Okay, so chapter 4 is going to be on individual behavior, and in particular how individuals make decisions with a budget in a type of indifference curve analysis. So alright, let me close all these files that I just did. I guess I already also closed the. Okay, so chapter 4. Alright, so you can open up under PowerPoint, the lecture for chapter 4. You can use the PDF link to the older textbook version, so I'll refer to that for some of the graphs. You can open that up. Okay, and then if you click on the chapter 4 section on Blackboard, at some point we're going to need the chapter 4 document and the chapter 4 homework. So let's go ahead and I'll just open those up now. Okay, here we go. All right, let me pull my copy up real quick. Give me 30 seconds. Okay, chapter 4. Okay, so let's first look at the concept of indifference curves. I'm not sure if you guys have seen these before, but they're pretty useful in explaining individual consumer behavior. So let's look at the first picture of an indifference curve. Alright, so a indifference curve kind of looks like this. And an indifference curve shows there's two goods, good Y and good X on the appropriate axes. And what the simple definition is, it's a curve that defines the combinations of two goods that give the consumer the same level of satisfaction. So basically, we'll come up with examples for two goods, but this is good Y. And this is good X. And along this pink indifference curve, each point gives the consumer the same level of satisfaction, which means he or she is indifferent between any of these points. All right. So along this curve, point A, point B, point C, and any other point on this specific curve, the consumer is indifferent and gets the same level of satisfaction. Okay, and you can see it kind of bows inward because, in general, most consumers prefer kind of a more balanced bundle, so they have like a good amount of both goods. And when you get to the extremes, okay, so the consumer already has a ton of Y, and therefore to get more Y, they give up a bunch of Y to get some X. So once you get to the extremes, normally your preferences for substituting get different, because if you have a bunch of one thing and less of another, you'd give up a bunch of that thing you already have a lot of to get some of the other. Okay, so that explains the shape of the curve, which kind of bows inward, showing that generally consumers have a preference for having a good amount of both goods. Okay, and then the slope of this curve is a concept called the MRS. Okay, and so the MRS, or the full name, is the marginal rate of substitution. This is the rate at which a consumer is willing to substitute one good for another and still achieve the same level of satisfaction. So that describes marginal changes along the curve, which is why it has to be the slope of this curve. Okay, and so you can see that the MRS changes from point to point because once you get to more extremes, you're willing to give up more of the thing you have too much of to get some of the other. So going from A to B, to get one more of X, the consumer is willing to give up two Y's. See? So here we have 6 Y's, 1 X, and if we want to go to point B, to get one more X, we're willing to give up 2 Y's. Alright, and then to get one more X, it's now a 1-for-1. So now to get to point C, you give up one more Y to get one more X. Okay, so the MRS, the rate at which you give up some goods to get more of the other changes. And as you get more up to this extreme, you're going to be willing to give up a lot more Y to get some X. If you get to this extreme, you're going to be willing to give up a lot more X to get some Y. So the rate of substituting changes, but it exactly defines the moving from position to position on a given indifference curve. Okay, so everybody following so far?
Yes.
Okay. Now, you'll probably like to see that, or you probably see that what the consumer's budget is determines where he or she can get to or consume on a indifference curve. So we're going to introduce budget constraints to show where consumers can achieve in consuming. So let's look at a simple budget constraint example or concept. So before that, if you look at figure 4.2 in chapter 4, you can see that there's 3 indifference curves on this figure. And so what we're showing here is that the consumer is indifferent on a particular indifference curve. So any point on a indifference curve 1 gives the consumer the same level of satisfaction, but going to consumer indifference curve 2, that would give the consumer more satisfaction. And the same with going to indifference curve 3. So indifference curves that are farther from the origin to the right direction are preferable, but getting to a higher indifference curve depends on your budget, which we're going to introduce now. Okay, so we're going to introduce a simple budget line, which is the bundles of goods that exhaust the consumer's income. So here's a simple equation that we're going to use a bunch of times. All right, so it's Px times X plus Py times Y equals M. So Px is the price of X. X is how much the consumer consumes of good X. Py is the price of good Y, and then Y is how much the consumer consumes of Y, and then M is income. Okay, so for this simple analysis, we assume the consumer spends all of his or her income, and so that means that you have to either buy, if we have good X and good Y, you got to buy one of the two things or both, and so therefore what you spend on X plus what you spend on Y should equal your income M, because you want to spend all your income in this simple example to get to the highest level of indifference curve or satisfaction. Alright, so we're going to put this budget line equation, the general form, into the same graph as the indifference curve with the Y and X axes. And to do that, all you do is rearrange to make everything a function of Y. So take a few steps algebraically and just divide by Py. Okay, you get that. And then if you subtract the Px, Py, X term from both sides, you get this. Okay, so all we did was rearrange the budget line to have everything as a function of Y so we can graph it or put it on the same picture. Okay, and so now on the Y-X axis, this is good Y and this is good X. Okay, so you're just plotting the graph, which is going to be a straight line that's determined by the slope is going to be determined by the price ratio. But here's the equation we just solved for. Okay, so if you want to get the intercept, the two intercepts, what is this function when x is 0? Okay, it's just this term m over py, which is this intercept. And then we don't have to do it right this second, but if you rearrange as a function of x, or I mean, if you find out what x is when y is 0, it's going to be the okay, so the two intercepts are determined by the income divided by that current goods price. So you can see that we'll do some changes, but you can see that when income goes up, this line is going to change, or when the prices change, this line is going to change as well. Okay, and the important thing you want to see for this is that the slope of this curve is negative the price ratio. Which is negative px over py. Okay, so right there you see that if any of those prices change for x or y, or both, then that's going to change the slope because that affects where the consumer can choose on this budget. So basically, anything along this budget line, the consumer is maximizing his or her budget. Okay, anything below, they're not spending everything. Anything beyond is not attainable because they don't have enough income at the current situation. Okay, and then we're going to see that let's put these two concepts together, the difference curve plus budget line on the same graph or picture, and it's going to look like this. All right, let's define, so the slope has a specific title, which is called the marginal rate of substitution. The market rate of substitution, and that's the rate at which one good may be traded for another in the market, which is the slope of the budget line. So we define the slope of the indifference curve as the MRS, the marginal rate of substitution, and we define the slope of the budget line as the market rate of substitution. Okay, so we'll get to this more when we look at the changes in equilibrium, but this shows that if your income goes up, your budget line shifts out because now you can afford more. And if your income decreases, if M goes down, then your budget line shifts to the left because now you can't afford as much. Okay, so if income increases, the budget line just shifts out with the same slope, and if it shifts to the left, it just goes the other direction. But if the price changes, then the slope of the curve, the ratio of the prices changes as well. Okay, so see here that if the price of good X decreases, now that good becomes more affordable. Okay, so if this price is lower, that means that the full term M over Px is bigger, because the good's cheaper, you can buy more of it, so this curve is going to shift out, and the slope is going to change to the new price ratio. And so if the income changes, the curve just shifts out or shifts in, and if the price changes, then it sinks out because the marginal rate of the market rate of substitution has changed, and now the price ratio is different. Okay, so notice the difference between income changes like this and price changes like this, where the curve kinks to the right or left, depending on which price has changed. Alright, and this one shows an increase in the price of good X, which means that now the consumer can afford less of it. The good's more expensive, so the amount we can buy is less, so it shifts to the left, which shows that the options of buying for good X are lower with the same income because now the good is more expensive. Okay, so here's the consumer equilibrium, which is the equilibrium consumption bundle is the affordable bundle that yields the greatest satisfaction to the consumer. Alright, so here it is. So this line is the budget line. Okay, and we have a bunch of possible different curves. And you can see that the one, we can afford lots of them, but the best one, or the one that gives the consumer the most satisfaction, is this indifference curve. Number 3, which is just tangent to the budget line. And that's because, this is preferable to indifference curve 1 and 2. But any indifference curve beyond that would not be attainable given this current budget line. So you can see that at point C, so remember the slope of the indifference curve is the marginal rate of substitution. The slope of the budget line is the market rate of substitution. And at this point, the slope of both terms is equal. So just looking at this, point A is achievable, but we can get more stuff. Point B is achievable as well, but we can also get more stuff at point C. And then point D is not, we can't get there yet because the budget doesn't allow it. So point C is the best this consumer can do given his or her budget line and given the indifference curve shape. Okay, so there you can see that the two concepts we discussed for the shape of the curves, the MRS for the indifference curve and the price ratio for the budget line are going to be equal at that point. So at that equilibrium, this is going to have to occur. Okay, so the only thing that's going to change the consumer equilibrium is a price change or the income change. Okay. All right. Everybody follow along so far with the consumer equilibrium?
Yes.
Okay. Next thing is let's make some changes to something in the equilibrium. Okay, so what happens if one of the prices changes or income changes? What happens to the consumer's equilibrium? What happens after the changes to where they get to their consumption point? Okay, so we can break this down into substitutes and complements, like we learned about in chapter 2, and normal goods and inferior goods when we talk about income. Okay, so here's the initial equilibrium for this consumer point A, where they're consuming X0 and Y0. But what happens if there's a decrease in the price of good X and good Y is a substitute for good X? Okay, so if the price of good X decreases, we know that the budget line is going to shift out because the consumer can buy more of it. So the first thing you do is change the budget line from this line. It shifts out to that pink line because now the price of good X is lower and the consumer can buy more X. So, and then the new equilibrium is going to be somewhere in the new budget line, but you have to know if these are substitutes or complements to get there. So you can see that this is a substitute because at the new equilibrium, the consumer buys Y1 and X1, which means that he or she bought a lot more X and less Y, which would have to mean that they're substitutes because at the new equilibrium, there's less Y that's being purchased or consumed. Okay, so remember this is like maybe good Y is Pepsi and good X is Coke. If the price of Coke decreases and the consumer is pretty indifferent between the two, they're going to buy more of the cheaper one, which is a lot more X and less Y. Okay, so the consumer is better off with any price decrease, but you have to make sure that in a higher equilibrium, make sure that you know if the goods are substitutes or complements, because with more income or with a lower price, it doesn't mean the consumer has to buy more of the other goods. Okay, well this one shows complements, which we know have a little different relationship. So this is like milk and cereal. Okay, so the price of good X falls, and in this example, the goods are complementary. They're complements. X is cereal, Y is milk. Okay, so initially at point A, where it's Y1 and X, or X0 and Y0, or I guess it's X1 and Y1, then the price of good X falls, which means the consumer can buy more of it, so this curve shifts out like this. So we go to the pink budget line. Okay, and then you can see the point B, the consumer buys more of both goods, so Y2 and X2, because these goods are complementary. So both these goods are consumed together, and basically this one, the consumer buy a lot more X, but also a little more Y as well. And the difference is the substitutes versus complements scenario. Okay, so what about if income changes? So we know that if the consumer gets more income, if M goes up, the budget line just shifts to the right like this. So if we're initially at point A, then we're going to go out to point B with a higher indifference curve because we got more income. And both goods are normal, so we're going to buy more of both of the normal goods. All right, so budget line shifts out, the indifference curve kind of jumps out in the same area, and we buy more X and more Y at point B. Okay, but what about if one of the goods is inferior? In this case, let's assume X is an inferior good. So we have an income goes up and X is inferior. Okay, so we start here at point A on this indifference curve equilibrium, and income goes up, which means the budget line has to shift out to the pink line here. But look at point B. So point B, the consumer gets to a higher level of indifference of satisfaction. But at the new equilibrium, they bought a ton more Y, but less X, and that's because we define X as inferior, which means that it has a negative relationship with income. So if income goes up, you buy less of it. If income goes down, you buy more of it. So because of that definition, if X is inferior, with more income, they got to buy less of it, which they did. Okay, so now we looked at the price changes for substitutes and complements, and we looked at income changes for inferior versus normal. And we can also break down the price change from one of the goods into kind of two effects, and that's called the income effect and the substitution effect. Okay, so what this does is it breaks down the effect into the substitutability part from the initial indifference curve and then the change in relative income when you get to a different indifference curve. So let's look at these two effects. All right, so the substitution effect is defined as the movement along a given indifference curve. So before you shift, that results from the change in the relative prices of goods holding real income constant. So when the price changes, what happens just substitutability wise? And then the second effect is the income effect, and this is the movement from one indifference curve to another that results from the change in real income caused by a price change. So you can break it down graphically into the two effects. Okay, so this figure shows, figure 4-13 shows, so we start at point A, and the price of good X increases. Okay, so that means that the budget line is going to kink in. Alright, so but before we do the shift, the budget line shift to the new indifference curve, the substitution place occurs on the initial indifference curve. So the substitution effect is the fact that okay, so if we start at point A and the price of good X increases, that means that good Y is now cheaper in relative terms because you now nothing happened to the price of Y, but the price of good X went up. So now just given that fact, you're going to go from point A to point B because you're going to buy more of the cheaper good, which is now good Y. Okay, so you're substituting more of the cheaper good for the more expensive good after the price change. That is the substitution effect. Now the income effect is going from B to C. Alright, so kind of ignore the pink budget line, but it's just for like alignment purposes, but this is the original budget line, this one. And then because of the price increase, it kicks into this one. So we're going to a lower indifference curve, and getting to point C is the fact that because one of the prices went up and nothing happened to our income, that this is like inflation, right? So because one of the prices went up, we can buy less. Our purchasing power went down due to essentially inflation. So that puts us to a lower indifference curve, which is point C. Okay, so first we do the substitution effect on the initial indifference curve. Okay, so after the price change, you buy more, you just substitute for more of the cheaper good. In this case, it's good Y. But then your purchasing power has gone down because of, essentially inflation. So that puts you to point C because your real income due to the price increase has gone down. And so that's the income effect. So substitution effect A to B, income effect B to C. Okay, and these depend on which goods price changes and if it goes up or down, but you always do the substitution effect first on the initial indifference curve, and you always do the income effect second, moving to a different indifference curve. Okay, so this concept's a little I don't know, a little complicated, but any questions on the substitution effect and the income effect, how you break it down on the graph and kind of what it means? Okay. All right. So next thing is you can use the indifference curve analysis to derive an individual demand curve. And so this is pretty simple but useful. You can go from here to a demand curve. So let's look at this graphical scenario. Okay, so here you go. So we're going from a change in equilibrium in the difference curve analysis to how that gives us a demand curve, and you can derive it graphically. So start at point A. This is the consumer's initial consumption bundle of X and Y on the difference curve, and then just put a point down here where you have the price of good X and the quantity of good X. Okay, so that's the initial price and that's the initial quantity of X. Then the price of good X decreases. Okay, so we know that the budget line that is pink out, the pink line, we're going to get to a new indifference curve, and assuming this is not a, well, either way, if the price goes down, you're going to buy more of it. So what we're showing is that the new point B, and the consumer bought more X because the price went down. So just down here, draw a second point with the lower price and the higher X. And what you've shown is that when the price goes down, the demand for X goes up, which is exactly the law of demand. So you essentially started driving a demand curve just by doing a change in one of the prices in the indifference curve analysis. So this graphical demand curve just comes from changing one of the prices. So again, all these models are looking at one individual's behavior, but this is kind of a link to the individual demand curve from this type of analysis. So this is how you would relate this to one person's demand curve for one particular good. Okay, so I think for the next few of these slides, we're not doing anymore. Or I took out of this chapter. So slides 8, 9, 10. We're not doing that, so don't worry about these slides that say like a calculus alternative. So I took these out, and then this is some other examples of income and substitution effects. So we covered what I want to cover in the PowerPoint portion for chapter 4. So we can close this. All right, so we're gonna take a break in a minute, but when we come back from the break, so on the chapter 4 document, first of all, there's some optional videos on indifference curves, income and substitution effect changes, and this, unless you really like calculus, you don't have to watch this. Okay, but when you come back from the break, we need to do some examples from chapter 4. And then I need to introduce the homework for chapter 4. But we've done all the main concepts for chapter 4, so we'll finish up the chapter 4 examples, get into the homework, and then we still got to do chapter 5, but I think we have enough time in the second 2 hours of the class. So let's take a break. Let's come back at 11 or so, or not or so. Let's come back at 11, and then we'll go from 11 to 1 for the second portion of the class. So let's take a 30-minute break, and I'll see you guys at 11.
Sounds good. Thank you.
Okay, you're welcome. Okay, and I'd recommend just staying logged into the meeting just in case something happens. So I'm going to take my sound off, but I'll stay logged in. Okay, looks like most people are still logged in, and hopefully you're back from your quick break. So let's go through the examples for chapter 4, and then I'll show you guys the homework for chapter 4, and then we still have chapter 5 to do. All right, so these are some select questions or adapted questions from the end of chapter 4. So let's go through these. So here are some good examples from chapter 4. And so this was in the chapter 4 document. Okay, so on Blackboard, under chapter 4, under the chapter 4 title, that's what we're looking at now. So let's do this. Oh, sorry, this is not it. All right, here we go. So the conceptual and computational questions at the end of chapter 4, or some of them. So number 1, we have the consumer has $400 to spend on good X and good Y. The market price of these two goods are price of X equals 10 and the price of Y equals 40. So part A is what's the market rate of substitution between good X and good Y. So remember, that's just the slope of the budget line. So the slope of the budget line is given by the negative PX divided by PY, the price ratio. And that is the defined market rate of substitution that we looked at in chapter 4. All right, so just take the general formula and negative PX divided by PY, put in the prices, 10 for X, 40 for Y, and therefore the market rate of substitution is negative 1/4. Okay, let's suppose income increases by $400, and how does this new $400 increase in income alter the market rate of substitution between good X and good Y? All right, and so you should, if you understand the model here, you should know that the price ratio is the only thing that determines the market rate of substitution. We're going to be able to buy more of both goods, but because none of these prices changed, PX or PY, so therefore the market rate of substitution isn't going to change because the prices didn't change, but the budget line will shift out. So nothing happens to the market rate of substitution because the prices did not change. Okay, so it doesn't alter the market rate of substitution, but the budget line will shift to the right, like we saw in those illustrations, and an individual would consume more of X and more of Y, but the same market rate of substitution, that same 1-to-4 ratio, because those prices did not change. Okay, so we got number 2, a consumer in equilibrium at point A in this picture. And also, we know that the price of good X is $5. Okay, so what is the price of good Y? Okay, so here's our general form for the budget line, PX X plus PYY equals M. Okay, we know that if we just rearrange and solve for everything as a function of Y, that it comes out like this. Y equals M divided by PX. n divided by py minus px over px times x. So that's the general form just that we rearranged in the chapter. Okay, so you can see that both intercepts, so we know the intercepts are defined as n over py and n divided by px, okay? So we learned that before from the chapter illustration. Now look at this graph here. You can see that both intercepts are 20. Okay, so if that's the case, if both intercepts are 20, then we know that the prices have to be the same because if n divided by py is 20 and n divided by px is 20, and the income's the same, then the prices have to be the same. So therefore, if both intercepts are the same and the price of good x is 5, then we're going to have also the price of good y is also 5, because the intercepts are identical. Okay, so we used a bunch of given information to get to this conclusion. So the price of x was given, both intercepts were given, and we know how to define the general term for the intercepts, and that led us to the fact that because the intercepts are the same, the prices got to be the same. Okay, so B, what is the consumer's income? All right, so we just determined the prices, and all right, let's plug in the prices to the little term here, m over py and m over px. All right, so both intercepts are the same, so we know that m divided by py is got to equal 20. M divided by px is got to equal 20. And then we know that, if both the prices are 5, m divided by 5 equals 20, and m divided by 5 equals 20. So there's only one thing divided by 5 that equals 20, and that's 100. Okay, so you confirm in both cases that income is equal to 100 given m over 5 for both is equal to 20. So you got to have the fact that m equals 100 because both intercepts are 20. Okay, next, at point A, how many units of good X does the consumer purchase? So here's our general form. Px X plus Pyy equals N. That's just the budget line. Okay, so we know the prices are 5, so 5x plus 5, and I believe this is given. Alright, so you can see at point A that we know the consumer buys 10, or consumes 10 X's, 10 units of good Y. Okay, so that's given. Okay, and we just found the income is 100. So we know that basically 5x plus 5 times 10 equals 100. Now, if we rearrange and solve through some algebra, we can find what x is because everything else is already given. So 5x plus 50 equals 100. Take away 50 from both sides, we get 5x equals 50, and 50 divided by 5 is 10. So that looks like it makes sense on the graph. Yeah, it does. And that's probably because both prices are the same. Both intercepts are the same, and so this number here is going to be 10. Okay, and then part D is suppose the budget line changes, like so that the consumer achieves a new income equilibrium at point B in the graph. What change in the economic environment led to this new equilibrium? Is the consumer better off or worse off as a result of the price change? All right, so we went from A to B, and obviously the consumer got to a higher indifference curve, so they're gotta be better off. But look at the new equilibrium. So at point B, going from A to B, the consumer consumes more Y, right? That went from 10 to 25. Okay, we don't need to solve for exactly how much X is at the new equilibrium, but it's less. We can see that at point B, the consumer is buying less X. So we know what happened to the price and the relationship between the two goods. Okay, so you can see because of the budget line shift, the price of good Y went down. You can buy more of it. That kinked out. And at the new equilibrium point B, the consumer bought a lot more Y and less X, which must mean that they're substitutes. So we've determined which of the price changes, or which of the things causes the shift in the budget line, and then the relationship between the two goods just by looking at the new equilibrium. Okay, so the price of good Y decreased because the budget line shifted kink up along the Y-axis, and the consumer is better off, obviously, because he or she got to a higher indifference curve. And finally, good X and good Y are substitutes because at the new consumption point, there was more consumption of Y and less X because probably the consumer substituted more of the cheaper good because it's just almost as preferable and it's now cheaper. So it substituted Coke for Pepsi or whatever became cheaper. All right, number 3. A consumer must divide 250 between the consumption of product X and Y, and the market prices are PX equals 5 and PY equals 10. Okay, so let's write out the budget line with this information. We'll start with the general form, PX times X plus PYY equals M. Okay, and just plug in the prices for PX equals 5, PY equals 10, and income equals 250. And we get this. 5X plus 10Y equals 250, and that's our budget line for these prices and this level of income. All right, part B, let's suppose the price of good X increases to 10 and the equation, write out the new equation for the budget line. And how does this alter the market rate of substitution between goods X and Y? Okay, so there's the new budget line. Plug in, the only thing that changed was the price of X went up to 10. So now it's 10X plus 10Y equals 250. Everything else is the same. The old market rate of substitution was this. Okay, so the old price of X was 5 and the old price of Y was 10. So that means negative 5 over 10. And the market rate of substitution before was negative 1/2. All right, but now put in the higher price of x, which is 10, and it's now in the same general form, negative px over py. Okay, now the price of x is 10, so that means that they're both 10 now. Negative 10 over 10 is obviously a rate of substitution of negative 1, so it's a one-for-one trade-off because the prices are exactly the same. Okay, so basically, if the consumer is going to give up 1y, it's going to get 1x. If it wants to go either direction, what they have to give up to get one more or the other is exactly 1 to 1. Okay, a consumer's budget line for two goods, this is number 9, is 2x plus 4y equals 500. Part A is, does the budget line change if the price of both goods doubles and the consumer's income also doubles? So both prices and the income double. What happens? Okay, so we start with this one, 2x plus 4y equals 500, then double the prices and double the income, which means that this is, 2 times 2 is 4, 4 times 2 is 8, and 500 times 2 is 1,000. So we doubled all the prices and the income, and you could probably figure out that if the prices double and your income doubles, you're pretty much back to the same place you started. You can confirm that by just dividing by 2, which would give us 2x plus 4y equals 500, which is just what we started with, because if you get more, you double your income, but the prices double, then you're at the same place because your income just gave you the same level because of the essentially inflation. Okay, so basically the budget line remains the same if all the prices and income double because you're pretty much in the same position. And then part B, so given the equation for the budget line, can you determine the prices of the two goods and the income? And this should be pretty easy because you've seen the general form many times, but you know that okay, given that equation, 2x plus 4y equals 500, you know what those numbers mean. You know that the price of x is 2. You know that the price of y is 4, and you know the consumer's income is 500, just based on the budget line specification. So you should be able to identify what those things are. The price of x is 2, price of y is 4, and income, M, is 500. Okay, so just some examples that help us understand the material from chapter 4, hopefully. Any questions on any of this information or these problems?
I have a question, Professor.
Yeah.
They had a graph, and I'm kind of confused on
This one up here?
question A and C. So where it says both intercepts are turning, that I'm clear on.
Okay.
So the PY is equal to $5. Is it because the price of good X is $5 that it's equal to 5 for Y as well?
Yes, it's because the price of y is given, and you know the intercepts are the same. So if the prices are the same, if the intercepts are the same, then the prices have to be the same, right? And
Okay.
so it's only because the price of x was given.
Right. Okay. So I'm clear on that. And then for part C, at point A,
Yeah.
that's 13. Never mind, I think I got it. Okay, so point A, that's 10. Okay.
You sure?
Okay, I'm good.
Okay.
Thank you.
You're welcome. Okay. Any more questions on any of these four examples? Okay, all right, let's look at there's a homework assignment for chapter 4 that is also due in 2 weeks. So let's look at that. Okay, so this is homework chapter 4 under the chapter 4 section on Blackboard. And there's just one question. All right, so we just run through the question and, yeah, so here's the one question for homework chapter 4, due in 2 weeks, next time, July 11th, or whatever that is. So let's suppose you won $15 on a lotto ticket at the local 7-Eleven and decide to spend all the winnings on candy bars and bags of peanuts. The price of candy bars is 75 cents, and the price of peanuts is $1.50. Okay, so this is just a simple budget line. We're going to do some moving around when the prices of income changes. Okay, so A, we have construct a table showing the alternative combinations of the two products that are available. And so what you want to do is just, so when I post my solutions for this, I did some of it in Excel. And so let me show you some of my example. You can do it in Excel, or you can do it just on a piece of paper, whatever's easier for you. Okay, so this is what I mean by table. Just a simple, so here, your income, your general equation for this budget line is going to be PXX plus PYY equals M. So that means that basically, pick one of the goods that's X, so 75 cents times X plus $1.50 times Y is got to equal your income. Okay, so you can see here that I did the table in Excel. You can do it in Excel, or you can just write it on a piece of paper, whatever you prefer to do. Okay, so these are all the and don't worry about like fractions of a good, so just whole numbers. So what combination of whole numbers give us exhaust our income of 15? So you can see that I've specified the equation right here, right? So this is basically the budget line, 75 cents times X plus 150 times Y has got to equal the income. So this is just a version of the budget line equation. Okay, so if you buy 20 candy bars and no peanuts, that will give you $15. If you buy 18 candy bars and one bag of peanuts, that'll also be $15. And all these combinations all the way down to no candy bars and 10 bags of peanuts will give you $15. So these are all the combinations of whole numbers where you're buying, various amounts of bulk goods that will exhaust your budget line. Okay, so that's basically what you have to do for for part A. Just make a little table like this, showing all the combinations that you can buy given the prices that will give you exactly $15. Okay, so do you guys see what I want you to do here for the table? Okay, and then part B is just to plot the data on your graph as a budget line. So plot the data in your table as a budget line in a graph. And again, you can do this in Excel, or you can just draw it with graphing paper if that's your preference. Okay, so if you plot all these points, basically, it should come out to a straight line, a budget line looking like this. Okay, so see, those are all the combinations that would be on our budget line. So there's 20 and 0 for candy bars. The other intercept is 10 and 0, and then all those should follow along. If you plot those in Excel, or you just draw it on a piece of paper, whatever you like to do. All right, so what is the slope of the budget line? And so you know that is the market rate of substitution, which is negative px over py. So that's easy. That's depending on which good is x. 75 cents divided by 150 is 1/2, negative 1/2. And the next part, what is the opportunity cost of one more candy bar and also of one more bag of peanuts? Okay, so this is basically every time you gain an additional good, what do you give up of the other? Okay, so look, basically it should always be constant, but every time you gain 2 candy bars, you give up 1 bag of peanuts, right? So that means that on a 1-to-1 scale, that every time you consume a candy bar, you give up half a bag of peanuts. Okay, and every time you gain a bag of peanuts, you give up 2 candy bars. So we've defined this in both directions. Basically, plus 1 candy bar equals minus 1/2 peanuts, and plus 1 peanut equals minus 2 candy bars. Right? It's the same thing, but in terms of the other. Okay, and then do these opportunity costs rise, fall, or remain the same as each additional unit of product you purchase? And you should know that the opportunity cost is the slope of the budget line, which is constant at the price ratio. And so the opportunity cost is the same as long as the price ratio doesn't change. Okay, and then part C is you're going to get more income. So you're going to do a shift where suppose that you had wanted $30 on your ticket, not 15. Let's show the $30 budget line in your diagram, and why would this budget line be preferable to the old one, which is clearly because you can buy more of both goods, you have more income. But for part C, is this? Yeah, so you can make a new table showing which combinations of X and Y give you $30, because that's now you, so the only thing that changed is your budget doubled, the prices are the same. Okay, so all these combinations will give me $30. So this is still 0.75x plus 1.5y equals income. Income is now 30, not 15. So all these combinations do it. 40 bags of peanuts, 40 candy bars, no peanuts. Okay, 36 candy bars, 2 bags of peanuts would also give me 30, all the way down to just buying only peanuts, would be no candy bars, and 20 bags of peanuts, also giving me 30. Okay, and then just draw the new budget line, which is all these points. So it's basically going to be, you shipped out the budget line by $15. Okay, but the slope is the same. Okay, so again, this can be done in Excel like I did as an example. This could be done on graphing paper or whatever you prefer to do for this one. All right, so questions on what I want you guys to do for the Chapter 4 homework? Okay, so once you're done with this one, this goes into the Chapter 4 discussion forum. Okay, which is right there. So we got, so far, we have the elasticity homework and the Chapter 4 homework, which are both due next week. Okay, and then now we have one more chapter to do, which is Chapter 5, and then assuming we get through this, you'll have the Chapter 5 homework as well. But Chapter 4 and the Chapter 5 homework are both pretty short. This might take you a little while, but you have 2 weeks to do all this stuff. Okay, so if we're good on Chapter 4 homework, etc., let's move on to Chapter 5. Okay, so you can open up to get all the stuff for Chapter 5, which is the last item of business for today. Chapter 5 PowerPoint. Okay, and we'll get to the chapter 5 graphs or here, so I can refer to those. Okay, and then we're going to get to the chapter 5 material, the chapter 5 Word document, and the chapter 5 homework. All right, so those are the last two things we're going to need for the rest of today's material, but I'll just open those up now. All right, so chapter 5 is going to be on the production side. So we're moving on. The first chapters, 2, 3, and 4 have basically been on demand, elasticity, and consumer behavior. Now we're moving into the firm side, and basically the rest of the class, because this is economics of the firm, is going to look at firm behavior, firm decisions, and different types of markets under different market structures. All right, so from this point on, we're basically moving on to the firm business side, and this will give us the intro to that chapter 5, which breaks down the simple production process and different costs of production. All right, so there's an optional video that you might have watched in Viz 500B, but if you want to look at some intro to revenue, profits, and price, this is like a 10-minute video. That's optional. All right, so let's introduce the production process. So this is just showing output for a given firm as a function of two inputs of production, which are going to be capital, big K, and labor, which is big O. Okay, so a production function defined is a function that defines, I don't know if you guys can hear, there's a car alarm going off here that, let me shut this window here, because, 1 second. Okay, so a production function is a function that defines the maximum amount of output that can be produced with a given amount of input. So Q is output. Okay, and that is simply a function of the two main inputs, which are capital and labor. So to produce a certain amount, they got to use a specified or a certain amount of capital and a certain amount of labor, or some combination of both, to get more output. So it's pretty basic for this model. That if the firm wants to produce more output, they have to increase capital, or increase labor, or increase both. Okay, but how much each unit is worth on the margin is very important, and we call these changes the marginal product, which is basically how output changes on the margin when you add one more unit of capital or one more unit of labor. Okay, so marginal product in general is the change in total output attributable to the last unit of input. So when the input changes, when you add one more capital, what happens to output? That's defined as the marginal product of capital, and when you add one more unit of labor, that's defined as the marginal product of labor. Okay, so these are both very important because it shows us what happens to our output when you add one more unit of the input, in particular labor or capital. Okay, then you can also, so depending on the price of the good we're selling, we want to see what the value of these changes are. So we call that this term which is the value marginal product. So this is so we know what happens to output when you change each unit of input, the MPK and the MPO, but how much is that worth for the firm? So that depends on the change in output times the price of the good, because this is essentially price times the new quantity. So it's essentially the change in revenue, which is the value to the firm of adding one more unit of each of the inputs. Okay, so the VMPL is the value marginal product of labor, which is just simply the price times the MPL, which is pretty self-explanatory. So when labor changes by 1 unit and you get hopefully more output and you multiply that by the price, that's the value the firm gets by adding one more unit of labor. All right, same with capital. When the firm adds one more unit of capital, they get an additional amount of output, and if you multiply that by the price, that's the value to the firm of that additional unit of capital. Okay, so you know that the value marginal product is defined officially as the value of the output produced by the last unit of input. So just like we discussed, you define those as the price times that specific marginal product. So the VMPL is the price times the MPL. And the VMPK is the price times the MPK. So just in a two input assumption, what's the value of adding one more unit of each of those inputs to the firm? Okay, so let's relate these to how much, so we know the value of each of or the definition of the value for each marginal unit, but what should the firm, how much should the firm choose? Like how much, if they keep getting, we know that if they get more revenue from each unit of input, then that's good for the firm, but they also have a cost associated, so they have to pay labor at the wage rate, and they have to pay capital at the little r, which is the rental rate of capital. And this is the rate at which the firm rents computers, the building. So this is what they pay to use the capital. So labor is paid at this rate per unit, which is the wage, and capital is paid at this rate per unit. So they have to pay for each unit they use and their inputs. Okay, and we're going to see that the condition in which they're going to do the best they can in this business, just using these assumptions, is to try to use to pay labor and to pay capital up to their value marginal product. So basically, to maximize profits, a manager should use inputs at levels at which the marginal benefit equals the marginal cost. So the marginal benefit is how much they get from adding more input of labor or capital. The marginal cost is how much they have to pay for those additional units of input. Okay, so basically, what that means in our definition is when the cost of each additional unit of labor is W, right, that's the wage rate, the manager should continue to employ labor up to the point where the value marginal product, the VMPL, equals the wage rate. Okay, so this is the condition in which, in theory, the firm would maximize profits or minimize costs, kind of same thing. So when the value on the margin equals the cost on the margin for labor, that's when the VMPL equals W, and the same goes for the capital term. Okay, so what we're saying is that if we just have labor and capital, and the value of each input on the margin is the VMPL or the VMPK, then the firm wants to employ labor up to the point when the wage rate they're paying is equal to the VMPL. So that's just like saying the marginal benefit equals the marginal cost, and the same with capital. Okay, so these conditions should tell you that the firm wants to try to go to this point. Because let's say like if this was bigger than the value of the marginal product is bigger than the wage rate, then the consumer can get more value by adding more labor units. But if the wage rate was bigger, then they're paying the workers more than they're getting in value. So conditions below or above this would either mean that they're not maximizing their benefits or they're paying too much in their costs. And so that's what both of these conditions say, is this is essentially the marginal benefit equals the marginal cost for both units of production. Okay, so everybody following so far? We threw a lot of terms out there, but just want to make sure you guys are following along. Okay, sounds like we're following along. Let me know if you have any questions. But the next thing is so we've defined the conditions, and now let's look at some specific types of production functions. So they got to take on some form if we want to analyze them. So there's three types we're going to look at in this class. Okay, you can do more complicated ones, but these are enough to make some good assumptions. Okay, so if the production function is linear, that means that output is a function of capital and labor in a linear format. All right, and we'll look into more of this in a minute. And if the production function is defined as a Leontief, this is an old French economist, I think. Okay, it takes this form, which looks a little weird at first, but it'll make sense once you see it in picture. And this shows that output is a function of capital and labor, but that capital and labor have to be used in fixed proportions, which we'll see. Or another nice one that we use a lot of is these two economists, Cobb and Douglas, coined this one called the Cobb-Douglas production function, and that shows that labor, or that output is a function of capital and labor in a nonlinear form in this nice k raised to the alpha, or k raised to the a, l raised to the b, and this has some nice properties in which you can analyze. So, okay, so we're going to put numbers in, but the three types of production functions we'll look at will take one of these forms. So we'll go into more detail, but this is an intro to the three types that we'll look at. Okay, so linear, like I said, production function that assumes a perfect linear relationship between all inputs and total output, which is Q has a function of capital labor, which is linear, like this. Okay, the Leontief is a production function that assumes the inputs are used in fixed proportions, like this. Now, it looks weird at first, but we'll do a little example which will make more sense, which basically means, like, to get more output, you have to have combinations like 2 to 1 or 4 to 1, and so you only get more output if you use that specific ratio. So like, I don't know, so if labor is, if you need 4 units of labor, and 1 unit of capital to make an additional unit of output, then it's a 1 to 4 ratio. And so the B would be 1, and the C would be 4, and you can only produce more output if you use it at that ratio, or it goes back to the lower level. Okay, so we'll do an example that'll make more sense. Okay, but basically this means that the capital labor has to be used in fixed proportions. Okay, and this last one that we'll look at more is the Cobb-Douglas version, which means the production function assumes some degree of substitutability among inputs. So capital and labor are going to take on this, where output is defined by A to the A and L to the B, like this function here. Okay, let's do an example, and this is going to be a demonstration from 5.1, which will help us understand, I believe, the Leontief version. So I did this one on the separate Word document, if you want to look at that. So this is the Chapter 5 document on Blackboard that I put up there. And so there's some optional videos that I'll run through here. There's intro to production functions. There's more on the value marginal product, and there's more on, we haven't got to this yet, but this is the marginal rate of technical substitution. All right, so bunch of optional videos that I'd recommend. So the first demonstration problem here, demonstration problem 5.1 is this. All right, so the engineers at Morris Industries obtained the following estimate of the firm's production function. How much output is produced when 2 units of labor and 5 units of capital are employed. So the general production function is this form, which is the Leontief. So it is specified as a minimum of 3K comma 4L. So this is the function. Alright, so it looks weird, but when you plug in the numbers, it'll make more sense. So basically it's saying that we have to have a 3 to 4 ratio of capital to labor to produce output. Okay, so this question said that we have, we're going to use 5 units of capital and 2 units of labor. So let's just plug those into the function. Okay, so capital is 5, we just plug it in right there, and labor is 2. So that means that Q is a function of 5 capitals and 2 labors equals the minimum of 3 times 5, which is 15, and 4 times 2, which is 8. And so you can see that based on this ratio, that we're only going to get 8 units of output because we got to use them in fixed proportion. So min means the minimum, the smallest number of 15 and 8. So what's smaller, 15 or 8, and that is 8. Alright, so this one's a little weird, but can we see what how this function is working? Okay, great. So let's go back to the PowerPoint. Alright, so let's look at what the marginal products are in relation to the different types of production functions. So we're going to do a little bit of calculus here. So hopefully I don't lose too many of you, but we'll do some simple. We'll do some quick derivatives to understand the productivity. So basically, the marginal products are we know it's the change in the input and how that changes the output, right? So that when you change the input by 1 unit, what happens to the output? And in calculus terms, that's just basically the derivative of the production function with respect to the unit of input. So the MPK is dQ dL. And, sorry, the MPL is dQ dL, the MPK is dQ dK. Okay, so we'll start with the linear one because it's easiest to take derivatives of. And so if the function is this form, AKBL, and to get the MPL, all you have to do is differentiate that Q function with respect to L. Right? So if you differentiate this with respect to L, it's just B because nothing else is being affected. So dQ dL is just B. Okay, so it's basically the slope of the linear relationship. And then if you differentiate it with respect to K, it's just A. Okay, or you can, you can always, this whole course is going to be basically open note, open book, so you can always refer to the full equation. I mean, you don't have to memorize this, but if you want to understand it in calculus terms, then differentiating this with respect to L is the MPL, which is A, or B, and differentiating this with respect to capital is the MPK, which is A. Okay, so you don't have to analyze the marginal products for the Leontief because it's got a weird form, but here's how you do it for the Cobb-Douglas. So if you have this form, which is the Cobb-Douglas, okay, you can get the marginal products of these. But you can get those by taking a simple derivative. So basically, when you have to do this in the example, you can either just use this general form here, or you can do a little calculus and just take the derivative, which is like this. So if this is our function, to get the MPL, differentiate that with respect to L. So that means that the K term is constant, but the B is the exponent. So you basically, like if the derivative of like x squared is 2x, or if it's x to the third, it's 3x squared. So remember, you always bring down the exponent, which in this case is b, and then you subtract 1 from the exponent. So if you bring the b down and subtract 1, it's b times k to the b, L to the b minus 1. Okay, so the MPL1 is if you differentiate the function with respect to labor, the exponent comes down, which is b. Capital isn't changing, so leave that there, and then it's times L, b to the minus 1. So you brought down the exponent b, you don't know what it is yet, and you subtracted 1 from it. So this is the calculus derivative of the general form of the Cobb-Douglas. Then you can do the same for capital, and so now we're doing it with capital, so the exponent for capital is a. So now it's a times k raised to the a minus 1 times L to the b, which is constant. Okay, so hopefully that makes sense. So you can either, when we do these, you can do the derivative in your head, or not in your head, but do the derivative, or the general form is always right here if you want to use these. All right, so questions on what I just showed you here for the MPL and MPK? Okay, what's next? All right, let's do another example, demonstration problem 5.2. All right, so I did this on the separate Word document. So I think I'm sure that on the homework assignment, there's a variation of demonstration problem 5.1, which we just did, and there's one like this one. So these are the two that you'll have similar examples in your homework. So let's do demonstration problem 5.2 here. All right, so a firm produces output that can be sold at a price of $10. So this is, it's like a little word problem. You gotta gather the information and then find the best option of labor. So the price of this good is $10. And the production function is given by the Cobb-Douglas specification below. So we put values into the A and the B. So it's basically K to the 1/2 times L to the 1/2. So A is 1/2, B is 1/2. Okay, if capital is fixed at 1 in the short run, so the good news is capital is going to be 1. We can ignore it for now, or just make it 1. How much labor should the firm employ to maximize profits if the wage rate is 2? Alright, so we got a bunch of information, and we got a production function, which is this one here. Okay, so K to the 1/2, L to the 1/2. And we know that since capital is fixed, we don't have to worry about that. But we know our best choice when basically marginal benefit equals marginal cost for labor is when the value equals the cost. So that, like we said, that is when the VMPL equals the wage rate. So that is the profit maximizing input usage for the unit of input, which is changing, which is labor. So we want to find the level of labor units in which this condition holds. So this is our goal right here. Alright, so first, we were told that capital is fixed at 1 because we're doing a short run analysis. So oftentimes in the short run, you assume the firm doesn't have the option of changing capital because that's a long run adjustment. So the only thing changing in this example is labor, right? They can hire more workers, they can hire less, but they can't change capital for this short run analysis. So, if capital is fixed at 1, just plug that into the production function. Okay, so Q equals F as a function of K and L, but K is 1, so let's just plug in 1 into this production function, and that means 1 to the 1/2 times L to the 1/2. And we know that anything, 1 raised to anything is just 1, so the production function simplifies to L to the 1/2 in the short run. Okay, so for the rest of the example, this is our production function, just L to the 1/2. Alright, now you have to find the MPO first, which is differentiate that function, L to the 1/2, with respect to labor. Okay, so the 1/2 is the exponent, so bring that down and then subtract 1 from the exponent. That is the definition of the derivative. So you should see that you get 1/2 L to the minus 1/2. So the 1/2 comes down, the 1/2 is like B, and remember if we look at this one, okay, that's the general form. So B is 1/2, and B minus 1 is 1/2 minus 1. So that means that it's 1/2 times 1/2 minus 1, and 1/2 minus 1 as an exponent is negative 1/2. Okay, so hopefully you see how we got this MPL here. Alright, so do we see how this is the MPL based on the derivative of dQ/dL? Okay, so was that a no? Or oh no, okay, that's from something else. Okay, so the MPO is 1/2 L to the minus 1/2. Now we need the VMPO, which is just the price times the MPO, or that's the definition. Okay, so all you have to do here is plug in P, which is the price, and that's given of 10. Alright, so 10 times our MPL of 1/2 L to the minus 1/2 is what goes here, and if we simplify this, 10 times 1/2 is 5. So that means the VMPL is 5L to the minus 1/2. Alright, so the final step is to set the VMPL equal to the wage rate, which was our condition to maximize input usage. So we're finally getting to this point. Alright, so VMPL is 5L to the minus 1/2, and the wage rate was given at $2. So 5L to the negative 1/2 equals is our VMPL. The wage rate's 2. Now the only thing that's to do left is a little bit of algebra and solve for L, and then that's the appropriate amount of input we should use for L. So let's divide both sides by 5. Alright, so we get L to the 1/2 equals 2/5. And then if we, I guess, raise both sides to minus 2 to get rid of the minus 1/2, then we get L equals 2/5 to the minus 1/2. And if you do this one, that comes out to basically 5 squared over 2 squared, which is 25 over 4. Alright, and then finally we get that the firm should use optimal labor, L star, of 6.25 units. So that's the that's the amount of labor they should use to satisfy this condition. Okay, so everyone good on this example? Okay, so back to the PowerPoint. Okay, so isoquants are basically a graph of the production function. Okay, so we looked at the different types of production functions. Now let's see what they look like graphically. Okay, so the isoquant in general defines the combinations of inputs that yield the same level of output. Okay, so if you look up here, this is units of K and this is units of L. So if we wanted to produce, as an example, 100 units of output, we can do that with any of these combinations on this indigenous curve, Q0. Now, if you want to produce more output, you have to use more of capital and more of labor. And if you want to produce even more, you have to use more inputs. So basically, any point along Q1, any of those combinations of K and L would give us 100 units. Any combination along this curve would give us 200 units. So you can use K and L at those different options. So you can see that you have options to produce a certain amount of output, but if you want to produce a lot more, you have to use more inputs. So each of these isoquants produces the same level of that specified level of output, but if you go to higher isoquants, that's using more. Okay, so let's define the marginal rate of technical substitution. And this is basically the rate of trade-off between K and L. That'll give us the same level of output. Okay, so the marginal rate of technical substitution is defined as the rate at which a producer can substitute between two inputs, in this case K and L, and maintain the same level of output. So we define this MRTS between KL as the ratio of the marginal product. So it's basically the MPL divided by the MPK. That determines the rate at which you trade off K for L and L for K and be on the same output curve. All right, and you can probably guess the slope of any given isoquant is equal to the MRTS. All right, so the rate of trade-off along this curve is always equal to the MRTS. Now that rate changes, but the definition is always the same. Okay, so we have three types of isoquant maps. So we define the three types of production functions. So either linear, or Leontief, or the Cobb-Douglas. So a linear relationship would look like this. That's how much output, or that's how much capital, this is how much labor. And each of these Q's are, so any point along this linear isoquant gives us Q0 output, and so on. So the relationship is linear, but going to a higher isoquant requires more inputs. Okay, so graphically, the one that was like the min KL looks like this, and that's because you're kind of defining it as fixed proportions. So when you're on this curve, Q0, and you go to the minimum point. So you can only get to the next output level if you use more of the specified ratio. Alright, so here, if you're here, and you use more capital, you're just going to go up a little bit. So you're not going to get to the next Q1 until you use the right amount of capital and labor. So you can't just use more of one or the other. You have to use more in the specified ratio. Here it looks like it's 1-to-1, but that depends on the specification. Okay, so I had to mute somebody because there was some background noise going on. So I think we're good. Okay, so in this one, this graph here for figure 5.5, this would be a similar to a Cobb-Douglas isoquant, right? Because the ratio changes, right? So it's kind of shaped like the indifference curve, and on this indifference curve, you can produce 100 units of output with any of these combinations of K and L. Okay, and therefore the rate of trade-off, or the MRDS, is the slope along the curve. So you can see it changes if you go from A to B. So you can see that to get the same level of output, you can use one more unit of capital, and you have to give up 1 unit of labor to do that. So therefore, from A to B, the trade-off is 1 to 1. Okay, but going from B to C, to get to that point, you have to use 2 more units of capital, and you give up 1 unit of labor. So the trade-off changes from 2 to 1, this one's showing C to D. Okay, so see here, it's C to D, it's plus 3 minus 1. So going from point to point is always defined as the MRTS, so it changes depending on where you are, because the rate of trade-off changes. So going from A to B, the MRTS is -1. Going from C to D, the MRTS is -3. Okay, so now we're going to bring in the cost functions of the respective firm. All right, so this is going to show how much we're in the chapter 4. We had the indifference curves and the budget line. Here for a firm, we have the ISO cost, ISO quant, and the ISO cost line. All right, so an ISO cost line is defined as a line that represents the combinations of inputs that will cost the producer the same amount of money. All right, so here's the general form. So you can see it's similar to the consumer budget line. Remember, we have PXX plus PYY equals M, and this is a similar analysis, but now we're looking at how the firm's costs are defined. All right, so W we know is the rate of the wage rate. L is how much labor we use. R is the rental rate of capital, how much we have to pay for each unit of capital. K is how much capital we use, and C is our total cost. So we know that if we want to spend our whole cost budget, we could spend it on capital, we could spend it on labor, or we could spend it on both. So how much we spend on labor, WL, plus how much we spend on capital, RK. If we want to exhaust our cost budget, then that has to equal C. So the total amount we spend, we're trying to spend all of our costs on either labor and capital, and this is how we define that equation. Okay, so let's put this on the same picture as the ISO cost, or ISO quant. Okay, so the ISO quant was on this, so we had K on the y-axis and L on the x, so we'll do the same with the ISO cost line. Okay, so to graph it on the same picture, you want to solve this equation, equation 5-1 as a function of K. K is a function of everything else, so you can plot it on the same graph. Okay, so take this, and let's, what do we do? Let's put WL, or you can divide by R, and then you can subtract W over R times L. So basically, all right, multiply both sides by 1 over R, you get this. W over R times L plus K equals C over R, and then just take this term and subtract it from both sides. All right, then you get this term. So you just rearrange to get K as a function of everything else. You can put it on the same picture. Okay, and then if you want to find out what the intercepts are, you want to see what capital is when labor is 0, then just put it in a 0 here, and the intercept is C over R. If you did the same for labor, you get that the labor intercept when capital is 0 is C over W. So similar to what we did in the budget line analysis, the intercept is determined by the total cost divided by the price of that input. Okay, so the intercepts change when one of the prices changes, or we want to spend more. Okay, but here is the ISO cost line, where K is a function of L, and the slope of this curve, what determines every point of this curve costs the same amount. Okay, and the amount at which we can trade capital for labor and cost the same amount is determined by the price ratio, which is negative W divided by R. So that determines when we move along this curve, we have to move at this rate, W divided by R. So if we want to use more capital and less labor, we're specified to use this amount based on these prices. Okay, so what happens if we want to spend more? So if we want to get to higher outputs, we increase our total cost. Increasing our total cost is just like shifting the curve out like this. Or what if one of the rates changes? So if the wage rate increases, we have to spend more for labor, so that shifts our curve out this way. Okay, the other direction. So it's just like a price increase. So if the wage, if either WR increases, that's more costly for us as a firm. So the budget line shifts in. So if, in this case, the wage rate went up from W0 to W1. All right, our budget line kinks in because now it's more costly to pay for labor, and so the amount of output we can obtain is not the same. It kinks in because we have to pay now more for the higher rate of labor. So when W goes up or R goes up, the budget line kinks in, and when it gets cheaper, we can get the same amount of output at a least costly rate. It would shift out. So this graph shows an increase in the wage rate. And this one shows a decrease in total cost. So we're spending less. Okay, and then you can probably guess, we're going to put the ISO quant and the ISO cost on the same picture and determine where the firm should use the appropriate amount of K and L to get their desired amount of output. Let's do that. Put them both together on the same graph. Alright, so this is either cost minimization or profit maximization, kind of the same way to say the same thing, but in this case, we're calling it cost minimization. So if the firm wants to produce 100 units of output, then the least costly way to do it is this point B, where you can see that the ISO quant is tangent to the ISO cost line. Okay, so any point below this point B, we are not producing enough units, and any point beyond point B is too expensive. All right, and you can probably guess that this condition is going to hold where the rate of trade-off is going to equal the ratio of the prices of the inputs, which means at point B, we should get that the slope of this curve, which is the MRTS, and the slope of this curve, which is negative W over R, is the same because they're tangent. All right, so we're basically saying that the firm is minimizing cost when the rate of trade-off of the two inputs equals how much they have to pay for those in the price term. Okay, so if the rate of trade-off changes or if the prices change, then that equilibrium point is going to change. But this condition in which they're minimizing cost is determined exactly by the rate of trade-off of the two goods and the prices they have to pay of those two goods. So this is like saying their total benefit and total cost is equal. At this point, when the rate of trade-off of the inputs they're using equals how much they have to pay for those two goods, for those two inputs. Alright, so if this condition did not hold, then the technical rate in which the producer could substitute between L and K would differ from the market rate at which he could substitute between the inputs. So if that condition didn't hold, then they're either paying too much or they could get to a higher output. Alright, so we're going to do a demonstration problem 5.3 in a second, but this shows that basically another way of saying this condition is that to minimize costs of producing a given level of output, the marginal product per dollar spent should be equal for all the inputs. Alright, so we're saying that on the margin, what we spend for labor which is MPL divided by W, should be equal to the MPK divided by R, and that's showing that the value on the margin between the two inputs is the same. And if we're doing that, we're maximizing profit or minimizing cost. All right, so let's look at example or demonstration problem 5.3. All right, so we're done with the PowerPoint. Up to slide 14, slides 15 and 16. We're not doing that for this class, so don't worry about this or this. So just know up to term 10, cost minimization. So we covered slides 1 to 14, and slides 15 and 16, don't worry about that. All right, so let's see. So 3 more demonstration problems for chapter 5. Then I'll show you guys the homework, and then that's all I want to do for today. So I think we're pretty good on time. Let's see. All right, I think we're pretty good on our last 20 minutes. Okay, so demonstration problem 5.3. So temporary services TS uses 4 word processors and 2 typewriters to produce reports. The marginal product of a typewriter is 50 pages per day, and the marginal product of a word processor is 500 pages per day. The rental price of a typewriter is $1 per day, and the rental price of a word processor is $50 per day. So the question is, these are our inputs, not capital labor, but we can use the same analysis. Is TS utilizing typewriters and word processors in a cost minimizing manner, which would mean that on the margin they're paying each of those factors the same, which is where this condition would hold. Okay, so let's see if this would hold for these 2 inputs. All right, so basically, is the marginal product of a word processor divided by the price we have to pay for it, so that's the value, is that equal to the same condition for a typewriter? So is MP word divided by the price of a word processor equal to the marginal product of a typewriter divided by the price of that input? All right, well, let's see. So the marginal product of a word processor is 500 pages per day, and that costs us $50 per day. The marginal product of a word processor for a typewriter is 50 pages per day, and that costs us $1 per day. Okay, so that means that on the word processor side, we're getting 10 pages per dollar spent, whereas on the typewriter side, we're getting 50 pages per dollar spent. So clearly, we're getting more value out of our typewriters than word processors. So we need to make some adjustments, but you can see that this condition doesn't hold, and we would have to use more word processors. Okay, so the answer is that marginal price per dollar spent on typewriters exceeds that spent on word processors, like this hold. This shows here in the condition. So word processors are 10 times more expensive than typewriters, but they're 50 times more expensive. So even though that they the word process is clearly more productive. It's way more costly, and we're spending too much on that. So the firm isn't minimizing costs at this choice. What they should do is use fewer word processors and more typewriters. All right, so next one is demonstration problem 5.4. So this one revisits fixed costs and sunk costs, which are key terms here. So Acme Coal paid $5,000 to lease a rail car from the Reading Railroad. So under the terms of lease, $1,000 of this payment is refundable if the rail car is returned within 2 days of signing the lease. So the questions are twofold. So one, upon signing the lease and paying $5,000, how large is Acme's fixed costs and sunk costs separately? And then two, one day after signing the lease, Acme realizes that it has no use for the rail car, but a farmer has a bumper crop of corn and has offered to sublease the rail car from Acme at a price of $4,500. Okay, so part two is should Acme accept this offer from the farmer to sublease the rail car. So it's basically like Airbnb for a rail car. Okay, so number one is what are the fixed costs and the sunk costs. Okay, so if they paid $5,000 to lease the rail car, that's already a fixed cost because that doesn't depend on output. So their fixed cost is $5,000. Okay, and what can they recoup? So they can possibly get a refund of $1,000 if they return it right away in 2 days. So that leaves their sunk cost, no matter what, just on the agreement, $4,000. So the most they can get back is $1,000 if they don't want it. But if they turn it back, they can get a $1,000 refund or credit. So the sunk costs are $5,000 minus $1,000, which is $4,000. Okay, then after 2 days, if they don't return it in time, they lose the whole $5,000. So you can see they get a better offer in part two. So if they don't need the rail car, they can lease it to Acme. So Acme is going to give them, they can lease it to the farmer with a bumper crop. The farmer's going to give them $4,500. So that's a much better scenario because they don't need it. They've already leased it, and they recoup everything except the $500. So they paid the $5,000. That's gone, but they get $4,500 back. So the net loss, I guess, is $500, but that's better than not using the thing at all and only getting $1,000 back. So really, it's better to take a total loss of $500 than a total loss of $4,000. Okay, so one more demonstration problem 5.5. For here, the next one down. Alright, so this one revisits marginal cost and variable cost and fixed cost, which we're going to use again in the latter chapters, 8, 9, and 10. And so here we go. The cost function for managerial enterprises is CQ equals 20 plus 3Q squared. Alright, and determine the marginal cost, the average fixed cost, and the average variable cost, and average total cost when our output is 10. Alright, so this is a nice quick review of these terms from BIS 500B, but just the marginal cost is the change in cost when you add one more unit of output. So the marginal cost of this is basically this DC dQ, the change in output when you change cost, the change in cost when you change output by 1 unit. So if you differentiate this with respect to Q, okay, so the 2 comes down, 2 times 3, and then 2 minus 1. So it's basically 6Q. But the question is, what is the marginal cost when Q equals 10? And that is 6 times 10, which is 60. Okay, what about the average variable cost? So the variable cost portion is the 3Q squared because, this is the fixed cost. It doesn't depend on Q. And that is the variable cost because it depends on Q. So we break it down into 2 portions. Fixed cost is 20 and variable cost is 3Q squared. So if the variable cost, or what's average variable cost? So average variable cost is where's the variable cost on average. So that's this variable cost divided by Q. Okay, so variable cost is 3Q squared. Divide that by Q, that gives us a nice 3Q. And when Q equals 10, 3 times 10 is 30. So the average variable cost when Q is 10 is 30. Okay, so what about the average fixed cost? That's just the fixed cost divided by Q. So fixed cost is 20, divide that by Q. So the average fixed cost is 20 divided by Q. Okay, so when Q is 10, what is the average fixed cost? Just plug in 10. 20 divided by 10, our average fixed cost is 2. Alright, then finally, what is the average total cost when Q is 10? So the total cost is the whole thing, 20 plus 3Q squared. And on average, just divide that by Q. Alright, and that is 20 divided by Q plus 3Q. Alright, if you divide by Q, the whole thing. But when Q is 10, this comes out to plug in the 10 for Q. Okay, so the ATC when Q is 10 is 20 divided by 10, and 3 times Q, which simplifies to 2 plus 30, which is an average total cost of 32. You can also confirm that the average total cost should be equal to the average fixed cost plus the average variable cost. So the two together, 30 plus 2, would also give you this result. So you confirm that this looks like the right answer. Okay, so questions on any of these examples from Chapter 5 before we look at the homework for Chapter 5? Okay, so let's open up under the Chapter 5 area in Blackboard. I had a homework assignment for Chapter 5 as well, so this is that one. Okay, so you basically have one on we did an example on the Leontief, so there's one like that. So you have a production function defined like this. Okay, just find out how much output would be produced when 100 units of labor and 100 units of capital are used. So you can look at the demonstration problem 151 for that example. Okay, number 2, you have you can look at demonstration problem 52 for this example. You have the price is $1. Here's the production function. And then if capital is fixed at 1, do the analysis and figure out how much labor should the firm employ to maximize profits when the wage rate is $32. All right. So there's a couple, the ones we just did in our Blackboard with the demonstration problems with the solutions. You can use those as an example, but I think you guys know what to do for these two. And this is for Chapter 5, so this goes here. All right, so there's your form for Chapter 5. Okay, so in 2 weeks, you have these, I guess, 3 assignments due. So the elasticity homework goes here. The homework for Chapter 4 goes here. And the homework for Chapter 5 goes here. Now, I think the Chapter 4 and 5 homeworks shouldn't take you too long. This might take a little bit of time because you got to do the analysis and answer all the questions. But you guys have plenty of time. You have 2 weeks to do these things, so I think it shouldn't take you too much time to do all this. And so we've caught up to the syllabus, so this should be accurate. Okay, so we did that stuff last time. And remember, if you're one of the few students who turn in the homework, get that in by tonight at midnight. And then, in the next few days, I'll post my solutions to the first 2 assignments you've turned in, and I'll get your grades up soon for the homework assignments. Okay, and we covered all this stuff today, so we're caught up to meeting 2. And then, just like it says in the syllabus, and like I just went over, these are the 3 things due next week.
Professor, for the exam, what is the exam going to look like?
It's going to be like there's so the homework questions, I've selected a few of them that I think are the most important, or good exam questions, and so it's going to be like, I can't remember exactly how many questions, but I've already written something similar, so I think it's maybe 5 bigger questions, but it's like a big homework assignment because everything is online now.
Okay, so it's not like it's timed or anything that we have to turn it in by, like started and then we have to finish it.
No, it's not timed because there's nothing like that because of the limitations. But yeah, so you have 2 weeks to do it. It's basically like just a longer, slightly more difficult homework assignment.
Okay.
Okay, and then so next meeting for next time. So I'll prepare a practice exam that we'll go through, and so that'll give you a good idea of what to expect for the exam, and then I'll give you guys the exam. So next time we'll go through a practice exam for the midterm.
Okay.
Okay, and then I'll give you guys the midterm, which will be due via email in 2 weeks, and then we'll also do Chapter 8, which won't be on the midterm, but we have to cover it next time as well.
Okay, that's fine.
Okay, so did I answer your questions on the midterm?
Yeah, thank you.
Okay, you're welcome. All right, so you know what to do for next week. Then next week we'll kind of summarize everything, do a practice exam. I'll give you guys the midterm. You have 2 weeks to do that, which is due here. And then you'll also have the Chapter 8 stuff, which will be due then. All right, so any questions on everything we've done today, etc.? Everybody good on the homework assignments, the ELAS system homework, etc.?
Yeah, we're good.
Okay, looks like we're right on time. So thank you guys for participating for another 4 hours or so. And I'll post this lecture on the YouTube channel. And once I get this thing uploaded, it takes a little bit of time, but I'll put this up by tomorrow. So if you missed anything in the lecture, want to watch some steps again, you can do that. And if you have any questions on the Excel work, any of that, let me know. So I think that's it for today. You guys know what to do for the next 2 weeks, and we'll meet via WebEx again in 2 weeks, which will be on July 11th. Okay, so I'll see you guys in 2 weeks. Email me if you have any questions. Everyone stay safe. If you're doing something on the 4th of July, be safe, and that's it for today. So thank you.
Thank you.